Hey, good afternoon, everybody.
Hi.
What's up? What's up, guys?
How y'all doing? Great to see everyone. If we can get those cameras on, we'd really appreciate it. My name is Calvin. I'll be helping lead these review previews from pre-algebra to algebra one. Super excited to work with y'all and hope this is really helpful. Uh, Dylan will be here as well.
What's up, guys? Yeah, I'll be helping out. I'll be in the chat. If you have any questions, shoot me a DM. And yeah, so this session is going to be focused on transitioning from pre-algebra to algebra one. So yeah, there's going to be a question going over all the major concepts that you should get down by the time classes start. So this is mainly for you guys, right? You guys are here to help yourselves. So if you have any questions at all, please make sure that you let us know. We're here to help you, and we can do that best if you are taking notes. Make sure you have a notebook or an iPad or something to write down on, all that good stuff. All right. And just make sure you ask all the questions that you may have. Sounds good? Can I get some thumbs up? All right. Awesome. Guys, let's get some more cameras on. All right. This is around 60 kids. We can get we got 60 students. So let's get a little bit more participation. All right. Let's get it going.
All right. Yeah, so grab a notebook, grab your calculator, make sure you have a pencil out, and let's get started. Let me go and share my screen.
And am I lagging at all?
No, you're okay. How do I sound? I need
Sound
there's
good.
background. Okay.
Yeah, no, you're good. You're good.
All right. Perfect. All right, so first topic is number properties and distance. And we're just basically gonna popcorn it. So we'll have someone read it, we'll walk through the question together, and then we'll popcorn someone else. So let's see, Tyler Lage.
Yep.
Hey, how you doing?
Hey, nice to meet you.
Nice to meet you. All right, go ahead and read number one.
Which of the following statements there's an error.
Sorry. All right, there we go.
Which of the following statements about rounding decimals is correct? A, the number 5.3464 rounded to the nearest thousands is 5.346. B, the number 5.098 rounded to the nearest thousands is 5.10. C, the number 5.7564 rounded to the nearest thousands is 5.757. D, the number 5.757 rounded to the nearest thousands is 5.76.
All right, perfect. So everybody, what let's see, this private message is Mr. Dylan. What answer you think is correct? And then we'll have him walk us through just how rounding works. So private message Dylan.
All right, guys, come on. Let's get some more DMs. I've got one person so far. All right, they're flooding in now.
All right, there we go.
What do
How's
you
it
mean
looking
by
right now?
Just send me a private message in the chat. If you open the chat and you click the little oval with the names, you can select my name and then you send a chat just to me.
All right, Mr. Dylan, how's it looking?
Pretty mixed bag. Yeah, pretty evenly distributed. A, B, a couple of C. Yeah.
Okay. So first thing, you want to make sure you know your terminology, right? So rounded to the nearest thousandth, right? Let's just go over how decimal places work, right? So we're talking about the number before the decimal, right? This would be like the tens, right? This would be the ones. And then the first one, right, would be the tenths, right? Tenths. First one after the decimal is the tenths. And then Dylan, what are the next few?
So we have that one after decimal point, then it's tenths, then it's hundredths, thousandths, and then that is like 10,000s, 100,000s, and so on and so forth. All right. So tenths, hundredths, and thousandths. So the key is when you have that S in the end, you're talking about the place after that decimal point, right? So if we're rounding to the nearest hundredths, for example, then we would have to look at the hundredths digit, which would be the second digit from the decimal point. That's the number we need to change. So to change it, we need to look at the number after it and see if it's 5 or more, we will go up. If it's 5 or lower, we keep it the same, right? So if we're rounding to the nearest thousandths, which digit are we going to be looking at? Jake Thomas, can you tell me what digit we're looking at if we're rounding to the nearest thousandths?
You'll be looking at the 10,000s place to see if it's 5 or higher or 5 or low.
Yeah,
so below.
Yeah, if it's 5 or higher, you round up. If it's 4 or less, you round down. Perfect. So with answer choice A, the number is 5.3464. So the 6 right there, that is the thousandths. So we're looking at the 4. The 4 after, the digit after. Since that's less than 5, we keep the 6 as is, and that's our rounded number. Make sense, y'all? All right, awesome. So any questions, or are we good to go?
We're good. Awesome. Our answer would be A, right? Again, if it was like 0.3467, you'd round up to 0.347, right? But here, less than 5, round, keep it the same. Perfect.
All right, CJ Lagos, you want to read for us?
Yeah.
All right. Can you read number two for me, please?
Sure. Which of the following statements is not true?
All right. So let's run through our answer choices, right? A is 99 times 0 times 43. Is that true, y'all? Send me a T in the chat if you think that's true. All right. Yeah. Anything multiplied by 0 is 0. So that's true. That's not our answer. So B, anything multiplied by 1 is going to be itself, right? So anything times 1 is going to be itself. So 46.5 times 1 is still 46.5. So that is true. All right. Then next one, 43 times 71 is equal to 71 times 43. Is that true, Gal? You can put that in general chat if you like. Whichever you guys prefer.
Yeah, it's everyone to start using the chat, okay? Just use the general chat. Yes or no, is this true? See.
Yeah, just. All right, yeah, everyone's saying it's true. Awesome. Yeah, you can switch around multiplication and it still works out. Perfect. Now, what about answer choice D? What do you guys think? Is that true? So, Brooke Vila, why do you say that answer choice D is false?
Because the 3 and the 2, like when it says the 4 and the 3, it makes a different outcome.
Right. So when you multiply 4 times 3, you get 12, right? And 12 plus 2 is 14. That's what we have on the right side there, what Kelvin wrote, right? And then 4 times 2 is 8. 8 plus 3 is 11. 14 is not equal to 11. So this is false. All right. So since we're looking for the statement that is not true, then D is our answer. All right. So whenever you have these types of questions, it is just 5 true or false questions. Which one is the right one? All right. Kelvin, take it away.
Perfect. All right, number 3. Let's have Isabella Cabrera. Can you read number 3 for us?
Solve 9 parentheses 4 minus 3 divided by 3 times 3 equals A 1
Perfect.
B 3. Okay.
Awesome. So yeah, right. 1, 3, 6, 9, or 27. So this is an order of operations question, right? So Isabel, how do you feel about order of operations? What would you work on first?
Parentheses.
Parentheses, right? So always remember PEMDAS, okay? Parentheses, exponents, multiplication, division, right? Addition, subtraction, right? Multiplication, division, addition, subtraction is do it in the order it appears. But again, good job. Always do parentheses first. So we get what? 9 times 4 minus 3 is? Isabel, you can walk with us through this one.
Sorry, 1.
You're good. 1, and then divided by 3 times 3, right? And now we have just 9 divided by 3, which is
3.
3, and 3 times 3 is
9.
9. Awesome, good stuff. Here, right? Anytime you divide and multiply by the same number, it essentially cancels out, right? So that's why we ended up with 9, right? Great job, Isabella. All right, Dylan, who's gonna be next?
All right, let's find someone to read for us. Let's see. Sarah Cecilio.
What are all the values of x if absolute value of x minus 2 equals 4?
Awesome, thank you. So absolute value is going to be those two vertical lines, all right? When you're trying to solve for absolute values, all you got to do is write that equation twice, and then make one of them make one answer negative, one answer positive, right? So you just get the absolute value of x minus 2 is equal to 4. Write that 2 times, right? Just so x minus 2 is equal to 4. And then the other one is going to be x minus 2 is equal to negative 4, right? So in the general chat, right? Not just to me, to everyone. What are the answers? Jake's got 1. Nice.
And if you want to double check your answers, right, just put it back into here, right? Put it back into, plug it back in for x, right? And see, is that number minus 2? Take the absolute value, makes it positive. Is that equal to 4, right? Just double check your answers.
Yeah, exactly. So answer is going to be 6 and negative 2. If you plug in 6, that's going to be 6 minus 2. That's going to give you 4, right? And the absolute value of 4 is just 4, right? And then the other option is negative 2. So negative 2 minus 2 gives you negative 2 minus 2. That's going to give you negative 4. And the absolute value of negative 4 is positive 4, right? So whenever you have an absolute value, it makes whatever is inside positive, all right? So positive to positive, or if it's negative, negative to positive, right? Awesome, still blowing up the chat. Love that. All right, let's keep it going.
So one more time, right? Anytime you have absolute value, you have to take into account there's going to be a negative and a positive solution, right? So just set it equal to the positive and negative of whatever's outside, okay? And you're good to go. And then whatever's inside the absolute value stays the same, okay? Okay, next up, let's have Amanda. Amanda A. Aguilar.
Express the values on the number line above as an absolute inequality.
Perfect. As an absolute inequality. So basically an absolute value, right? So first of all, what do we know about the numbers? They can be what? An absolute inequality. So what are the possible values that are acceptable? Let's say we call it x. X can either be what? Greater than or equal to, if anyone wants to say in the chat, greater than or equal to what? So these are the values in the number line, right? So we can see that if it's a solid line, right? First thing, if you want a solid dot, is going to be it's going to include that that number, right? So it's going to be greater than or equal to or less than or equal to, right? If it's an open circle, it's not going to include it, right? So it's just going to be a less than or greater than, okay? So that's why I said x is going to be greater than or equal to what value? So we're looking right here. Those are the acceptable numbers.
So yeah, what's the smallest number that x can be?
And since it's solid, it's going to include that number, okay? An open circle would not include it, right? And let's see some more answers in the chat. We have a bunch of you. So x has to be greater than or equal to, awesome, -3, or less than or equal to what in the chat?
So this would be the biggest
-1.
number, the biggest number x can be, right? So the smallest it can be is -3. The biggest it can be is -1. And if you look at the little line graph, that's where the little black bar is. It goes from -3 to -1. So it's going to be your smallest value to your largest value. All right, since it's a solid filled in circle, we are including those points. We're including -3 and -1. If it were open, if it were empty, then we would not include it, okay? So it can get really, really close to -3, but it wouldn't actually get there, right? But in this case, we're including that number.
Perfect. And this one's asking us to write it in like an absolute inequality form. Dylan, do you want to walk us through how to approach that?
Yeah, sure thing. So right now we have our little range, right? So we know that -3 is smaller than x, is less than or equal to x, right? So x can be between -3 and -1, okay? So absolute inequality, right? So that means that absolute, what does that mean? We hear absolute, what we just went over a question with the word absolute in it. What does that remind you guys of? You can unmute, you can say it in the chat. All right. Absolute something. How far something is from 0? Yeah, that's another way of saying absolute value. Hannah, thank you. Perfect. All right. So absolute meaning absolute value. Okay. So it's going to be an absolute value with an inequality. Okay. So here, if we can put little, if we put the little absolute value bars, right? So the absolute value bars, what they mean, just the absolute value with a number in it, all it's asking is how far away is this number from 0, right? So -4 is 4 units away from 0. Make sense? Can I get a thumbs up? -4 is 4 units away from 0. Cool. Now, what if in this graph, are we counting 0? Is 0 part of the numbers x can be? No. So we can't use just absolute value. We need to change something. Okay, so inside the absolute value, we have our x, right? And we also need to move that whole thing back because we're not at 0, right? We are at -2. We have to move it, okay? So how we're going to do that is we subtract whatever that middle value is. So instead of it being 0, what's the middle value? What's the value in the middle of that little black bar? -2, all right? So we're subtracting a -2. So if we have an x and we're subtracting a -2, Paula J, can you tell me what we're going to write? It's going to be an x subtracting a -2.
You would put x minus 2.
So it'd be x.
Distribute the negative sign to the -2. That makes it positive.
Exactly. So inside we're writing an x plus 2, right? So the reason why we're putting that 2 in there is because the center is not 0. Okay, so there's our absolute. There's the absolute value. All right. Now we're going to be an inequality. So x can be any number between -3 and 1, right? So if it can be anything inside of that, is that little distance going to be less than or greater than? If it's going to be inside of the values, it's going to be shorter. Is that going to be less than or greater than?
So here's like a really easy formula that you guys can remember, right? So anytime you want to figure out an absolute value function, okay, just remember it's going to be x minus a, absolute of x minus a, right, equals, if this is like a, we're not talking about inequality, just absolute value equation in general, equals d, right? So d is the distance, okay? A is any number, okay? Distance from any number, okay? So here we're talking about the distance from -2, right? So guys, from -2 to -1 is a distance of what in the chat? We're going how, like, what's the total distance? And distance is always positive, right? -2 to -1 or -2 to -3, we're only talking about a distance of 1, okay? Awesome, right? So the distance we're going away from -2 is just going to be 1. So we always just said equal to the, I mean, it'll be less than equal to a distance of 1, right? And then that would be the absolute value equation, okay? And then just remember, anytime you have absolute value functions, okay, with inequalities, the way you find out the two solutions is you just write the one of them just as it is, right? It would be what? X plus 2 is less than or equal to 1, right? So that's, we just basically copy it down, get rid of the absolute value, right? And here, right, we subtract 2, we get x is less than or equal to -1, right? Which is what we got, right? X has to be less than or equal to -1, right? And then the other absolute value equation is just going to be, you write the same thing, right? X plus 2, and the rule is you have to flip the inequality sign, right? So it'd be greater than or equal to, and you flip the number. Remember, you only flip the inequality sign, right? So it'd be greater than or equal to -1, and then you subtract 2 on both sides, right? And we know that x has to be greater than or equal to -3, right? So that would be how you would solve the absolute value function, okay? And as you can see, it lines up with what we wrote down initially, okay? Give me an A in the chat if you like have a better understanding of absolute value and how they work. It could be a little tricky, right? So just make sure you're reviewing it.
Yeah, absolute value is just asking how far away is this number from another number, right? So absolute value just by itself gives you how far away is it from 0. This way with the x minus a says how far away are we from a? So that's what this equation is telling us.
All right, awesome. Okay, Dylan, who we got next?
We've got Jordan Barrows.
For what value of x does absolute value of x plus 1 minus 1 equals -2?
Perfect. All right, so we've got an equation right here. It kind of looks like the equation we had before, right? Jordan, what can we do to this to make it look more like the original equation? That like x minus a equals d thing.
I'm not sure how to like start it first. I'm a little confused on how you did the first one.
No worries. So we just want to make that equation in the question look more like the equation, the formula we have, that x minus a equals d. So what's different about it? The difference is that we have a -1 with the absolute values. We don't want that there. All right, so we can move it to the right side. How do we do that? How do we move the -1? We got to add it, right? If we have a negative, if we add, we get rid of that. All right, so if we add 1 on both sides, we're going to have the absolute value of x plus 1 is equal to -1, right? Now, can the absolute value give you a negative? Can the absolute value of 4 be -4 be -4?
I don't think so.
No, absolute value always gives you a positive. So does this question make sense? Absolute value of x plus 1 equals -1. Is that possible?
No, it's not possible.
No. So how many solutions are there? What's the solution?
No solution at all, then?
There's no solution, right? Because it's asking for a negative distance. There's such thing as -30 miles. No, that's not a thing. It's just 30 miles. All right, so this has no solution.
Perfect. So just to reiterate, anytime you take an absolute value of a number, right, it's going to always end up being positive, right? So there's no way we can take an absolute value and get a negative number, okay? Even if you had absolute value of -1, it would just equal +1, okay? Because absolute value always makes the number positive, okay? All right, so yeah, no solutions in this case, right? And again, we're kind of going to teach you like little strategies that are going to apply to any kind of test, especially like standardized SAT, ACT, right? So let's say you didn't know how to deal with the absolute value. All you would have to do here is plug in these numbers in for X, right? And see which one would end up with a true statement. And A, B, and C would not work, okay? You wouldn't get an answer that is true, okay? Awesome. So now we're dealing with fractions, right? Adding fractions, subtracting fractions, multiplying, dividing. Make sure you're comfortable with all of that. So let's see. Dominic? Dabdul?
What does 3/5 plus 1/8 plus 1/5 equal?
Perfect. So Dominic, whenever we're adding fractions, what's the rule?
That you need to find the common denominator.
A common denominator, right?
Yeah.
So right now we have 5, 8, and 5, right? So what's the least common denominator that we can get from 5 and 8? What do you think, Dominic? Or in the chat, everyone in the general chat, what's the least common denominator we can get from 5 and 8 in the chat? Cool. And easy way to do it is if you can't think of a number, right? It's just all you do is you multiply the two numbers, right? So 5 times 8 is 40, so we can have a denominator of 40, okay? So we know that we need to get something over 40 for everything, right? So the rule whenever you're getting a common denominator is you need to multiply by a number over itself, right? Because anytime you multiply something over itself, guys, anything over itself, like for example, 2 over 2, 4 over 4, x over x, anything over itself always equals what? You divide something by itself, you're always going to get 1, okay? So when you're getting a common denominator, you're just multiplying by 1. All you're doing is you're making the number look different, right? So in the chat, let's see. What are we going to multiply 3?
You wrote 4 over 5. Sorry.
Oh, sorry. 4
yeah,
4.
No, 4 over 4.
Anything
Yeah.
over itself. Thank
you.
Good catch. All right, so guys in the chat, what are we going to multiply 3 over 5 by to get a denominator of 40? And remember, I want you to be very specific because 8 is 8 over 1. Okay, so we're not multiplying by 8. I get what you're saying, but it's not 8. 8 is 8 over 1. We're multiplying that fraction by what? 8 over. There you go, right? Okay, it's 8 over 8. Okay, so make sure it's a number over itself, okay? Because 8 over 8 is just 1, so we're not really changing it, okay? We're just going to change how it looks, okay? And then in the chat, what are we going to multiply 1 over 8 by?
And we want to make the 8 into a 40. What do we need to multiply by?
We want to make it 40, right? Awesome, right? 5 over 5, because again, 5 over 5 is 1, so we're not changing it, right? And then lastly, what are we going to multiply 1 over 5 by? And remember, we want to get the denominator to be 40, right? 1 over 5 we multiply by 8 over 8, right? Cool. So one more time in the chat, when we get a common denominator, are we actually changing the number? Yes or no? Are we changing the numbers? We're not, right? It's just the same number. We're just changing how it looks, okay? So now 8 times 3, what's that going to be? 8 times 3? 24, so 24 over 40 plus 5 times 1. Just going to be 5, right? 5 over 40 plus 8 times 1 is just going to be 8 over 40. And then the rule is when you have the same denominator, you're only going to add what? The top, okay? You have the same denominator, you just add the top, okay? So 24 plus 5 plus 8 is going to be equal to what? Amazing. 37 out of 40. Great job.
Nice, guys.
Leave it up there for a sec. So remember, anytime you're adding or subtracting fractions, you need a common denominator, okay? common denominator. All right. Amazing. All right, Dylan, who's gonna be next?
I don't know. I like the idea of Audrey Webb reading for us.
Which choice is the largest value?
All right, cool. So we have which one is the largest value, right? So key thing with this one, when you have a fraction, the top number, that numerator, that makes the number bigger, right? And also, when you are multiplying by a decimal, that also makes it bigger. Okay, so guys, what are you guys thinking? So if the top number is big, the number gets bigger. If the bottom number is small, it also gets bigger. So what are you guys thinking? In the chat, you can unmute.
So basically, right, if you divide by a decimal, you're gonna end up with a bigger number than whatever's on top, right? If you divide by like a bigger number, you're gonna end up with a smaller number, right? So here, let's just say bigger or smaller, okay? Let's look at A. If you divide 1 by 0.2, are you gonna end up with a number bigger than 1 or smaller than 1? B or S? Bigger, right? It's gonna actually be like 1 divided by 0.2 is 1 divided by 1/5, which is 1 times 5, right? Dividing by like a decimal, same as multiplying by like the reciprocal, right? So this would actually be end up with like a bigger number, right? Here, 0.2 divided by 3, when you're dividing by a bigger number, is this number gonna be bigger or smaller? This is gonna get bigger. This is gonna get smaller, right? 0.2, obviously not doing anything here, right? 2.2 times 0.02 is gonna get smaller as well, right? It's gonna be it's only 2% basically of 2.2 is gonna be get much smaller, right? And then finally, 0.2 divided by a bigger number is also gonna get much smaller, right? So what's the answer in the chat, guys? Which is the only one which one's gonna be the largest value? A, awesome, right? Because if you think about it, if you want to write it as a fraction, like 1 divided by 0.2, 0.2 is the same thing as 1/5. 1/5 is 0.2, right? So dividing by 1/5 is the same thing as 1 times 5/1, which is going to be 5, right?
This division is like asking, how many times does 0.2 go into 1, right? It fits in 5 times. So the number gets bigger. So when you're dividing by a smaller number, the number gets bigger.
Yeah, and this is a concept you're going to learn too, right? When you divide by a fraction, it's the same thing as multiplying by the flip of the fraction. Okay, keep, change, flip, right? Keep the top, change the sign, flip the fraction. All right. All right, number 9. Let's have Hannah Potter. Can you read the question for me?
Seamstress is cutting a thread into smaller pieces. If she uses 1/9 meter of a thread to make a single piece, how many pieces can she make with 2 meters of thread?
Perfect. So this is a great example of fractions and setting up like ratios. Okay. So who feels like they would know how to set this up? So we know that 1/9 of a meter, and if you want to set it up, right, you can say 1/9, right? We know 1/9 of a meter. We can just kind of write it like this, makes just 1 piece, right? Let's say 1 piece. 2 meters, we got to figure out how many pieces, right? How many pieces? How would you guys solve this question? Anyone?
you would do 1/9 times all the answers to see which one equals 2.
1/9 times all the answers. But we know that what 1/9 of a meter would make 1 piece, right?
So yeah, if you get
Mhm.
1/9 multiply it by the answer choice, you're supposed to get
Yep.
2, right? So
That's awesome, yeah.
if multiplying gets you to 2, how can you work backwards, right? How can you work backwards from multiplication? So Gabriella's got it. You guys catch that? So if you divide 2 by 1/9, you're asking how many times does 1/9 go into 2? All right, so 2 divided by 1/9. Right? That's asking how many times does 1/9 go into 2? How many times does 1/9 go into 2?
Let's see who remembers, right? Dividing by 1/9 is the same thing as multiplying by what fraction, guys? Dividing by 1/9 is the same thing as multiplying by 9. Awesome, right? By 9 over 1, right? Which is going to be equal to what? What's 2 times 9? 18. Awesome, right? So really good job, right? So the same thing as multiplying. If you multiply 18 by 1/9, you're going to get 2, right? Because 2 meters is going to make 18 pieces, right? Another way you can do this is you can say, okay, 1/9 of a meter makes 1 piece. We'll say one piece, right? Equal, so we can set up a proportion, right? 1/9 makes 1. 2 meters makes how many? We could just say x, right? So, and you could just solve for x, right? Okay. By cross multiplying, you would say 1/9, which is exactly what we said. 1/9. When you cross multiply, the 1/9 of x equals 2 times 1. So cross multiply 2 times 1 is 2, and then multiply both sides by 9, right? And you get x equals 18 pieces, right? 18 pieces. Great job. You guys are killing it. Cool. All right, next question, number 10. Who we got, Dylan? And Gabrielle, really, really great job.
Yeah, it's an awesome connection. Ryan in the chat nailed it. Going 9 pieces makes 1 meter, so 18 makes 2. Perfect. 1/9 goes into
really great,
1.
right? So we can basically multiply this by 9, right? 9, which means that would be 1 meter, right? 1 meter makes 9 pieces, right? And then multiply by 2 meters makes 18 pieces, right?
Awesome.
Cool.
Yeah, so I was thinking, let's get Murphy Bond. You want to read for us?
What does 2/7 plus 1/3 plus 1/4 equal?
Awesome. So we're adding fractions, guys. What do we need? Everyone in the chat, what do we need to add fractions? Gabriella, I saw you raise your hand. Do you wanna just yell it out?
The common denominator.
Exactly. Awesome. Common
Hey,
denominator. All right. But this time we have 3 different denominators. All right. So we need to find a common denominator across the 3 numbers. How are we going to do that?
And would you guys start with the multiples of the bigger number or the smaller number? Let's see, bigger or smaller? B or S in the chat. And Dylan, what would you start with?
So if you writing out the multiples of 3, you got to write 3, 6, 9, 3, 6, 9, 12 all the way and work all the way up. If you start with the bigger numbers, then you know what the big values are that you're building up to. So I would start with the bigger numbers. So if we start with 7,
me too.
What are the multiples of 7?
7, right? So 3 and 4 don't go into 7, right? So 7 won't work, right? 7, and that would be what? 14. That wouldn't work, right? 3 and 4 don't go into 14. 21. 3 and 4 going to 21. Nope, only 3, right? 28. 3 and 4 going to 28.
Just get a Y for a yes or an N for a no. Do 3 and 4 go into 28?
Nope, only 4 does, right? 3 does not. And then 35, right? We know that 3 and 4 do not go into 35, right? What's the next one?
42, I think. I don't know. I haven't done
42
multiples in a while.
Does 3 and 4 go into 42? Nope. So guys, keep going. So I want you guys to take a second, right? This is a really good kind of practice, right? Figure out what is a denominator that 7, 3, and 4 would both go into. And then we'll talk about a shortcut that would give you like a. So I see 72. Interesting. So 72 is 7. Does 7 go into 72? Nope, right? 72 divided by 7, right? 72 wouldn't work. So you keep doing this, right? You keep going, right? But let's pause here, right? So this would be one way to do it, right? The shortcut would simply be, let's go ahead and then we keep doing this until we get to 84, right? We know 84 is going to be multiple of 7, 3, and 4. But guys, pick up your calculator. What is 7 times 3 times 4? So remember what I said, if you have two denominators, two different numbers, you multiply both of those numbers to get a common denominator, right? Same deal with if you have 3 numbers. If you have 3 numbers, multiply those 3 numbers to get a common denominator, right? It might not be the least common, but it's going to get you a common denominator really quick, okay? So awesome, right? We know that 7 times 3 times 4 is going to be 84, okay? So we know the denominator is going to be 84, right? So let's go ahead. Now, this first fraction, right? 7 times what is 84? $12, right? So we're going to multiply by what? And let's see if you guys remember how I want you to write this. You multiply this fraction by 12 over 12, right? Because 12 over 12 is 1, right? So we're not changing it. 12 over 12. And we multiply this second fraction by.
In case you're wondering how they're getting 12, that is 3 times 4, right? So 7 needs to be multiplied by 3 and 4 to get to 84, right? So if you multiply by 12 over 12, get to the 84. Now, what about for 1 over 3? How do you get 3 to 84?
It's a great way to look at it, right? So yeah, so we know 7 times 3 times 4 is gonna give us 84, right? Because 3 times 4 is 12, right? 3 times what is gonna give us 84? 3 times 7 times 4. And what's 7 times 4? 28, right? So it'd be 28 over 28. And let's do that one more time. We multiply 1 over 4 by essentially 3 times 7, right? Which is going to be 21 over 21. Awesome.
Yeah, they got it. They got it. They're blowing up the chat.
Great job. All right, so let's quickly finish this, right? So we're going to get 12 times 2. When you're multiplying fractions, just go straight across, right? So 12 times 2 is going to be 24 over 12 times 7 is 84, right? Plus 28 over 84 plus 21 over 84, right? And again, when you're multiplying, go straight across. Now, when you're adding, you only add the numerator. Once you have a common denominator, you add the numerator. And what's your final answer going to be, guys?
All right, got 73 over 84 in the chat. Awesome, guys. Yeah, you just add the top numbers. That gives you 73. And then you just keep the same denominator. You keep the 84. Perfect. And guys, This was a long question. All right, you gotta get the factors, you gotta multiply, by common denominator and all that. Takes forever. All right. Just because it's a long question does not mean that you're doing it wrong. All right. Sometimes questions just take a while. All right. So if it's taking a long time, don't get discouraged. Just keep on going. All right. You guys are smart.
And I know you guys are tempted. Oh, why would I do this question? I could use my calculator. Well, guess what? On like standardized tests like SAT and ACT, like specifically the SAT, there's like a no calculator section, right? So this might be a no calculator question where you have to add them and then bubble in the answer. So you have to know how to get a common denominator, okay? And add. Cool. Who's gonna be next, Dylan?
I was thinking, I already called Brooke. Alexa Martinez.
Which expression is equivalent to 5 to x plus 9?
Awesome. What's the order of operations real quick? Just kidding. We don't need that here. All right. We can't combine anything. What do we need to do here? Leah.
Distributive property.
Yeah, distributive property, exactly. To distribute, that just means you gotta multiply the 2x times 5 and the 9 times 5. Perfect. Distribute that 5. All right. So there, all you gotta do is multiply those numbers together. What are you gonna get? Nice. Awesome, guys. Yeah. 2x times 5 is 10x. And 9 times 5 is 45. So 10x plus 45. Perfect.
Awesome. All right, some more fractions. Let's have Jacob. Jacob Riley? Really?
Find the missing value in the equation 2 3 to the 8th plus question mark over 8th equals 3 1 to the 4th.
Beautiful. Okay, so this is dealing with like complex fractions, right? So how would you break this up? For example, 2 3/8, 2 3/8, right? Do you know how you would write this as one fraction, Jacob?
Not really.
Okay, and I see someone raise their hand. Who raised their hand? Leah.
Do you make it an improper fraction?
Amazing, right? So this is an improper fraction right now, right? So 2, how would you rewrite 2? Right now it's 2 over 1, right? As some number over 8. What would you multiply 2 on? 2 over 1, how would you get that over 8? 2 over 1 is the same thing as what number over 8? Leah.
Oh, I'm sorry. 4 over 4.
Good, right? Because you, well, almost, not 4 over 4. You want to get some number over 8, right?
Sorry, I'm confused.
You're good. So the number 2, right? In order to combine it with 3/8, we have to rewrite it as, so 2, we have to basically rewrite 2 over 1 as some number over 8, right? So we need the denominator to be 8, right? So you multiply by what?
If our denominator is 1. Yeah, if our denominator is 1, right? Whenever we have just a whole number, we have just a 2. That's actually 2 over 1. All right. So 2 over 1, we want to make it into something over 8. So we multiply the denominator and the numerator by 8 to get that whole thing over 8. So 2 is actually equal to what over 8? You can unmute in the chat, whatever you guys feel. So
2 is what number divided by 8?
So I'm getting some 4 over 8 and I'm getting some 16 over 8.
So 4 divided by 8 is 1/2, right? That's not going to give us 2. We want 2 over 1. So what number divided by 8? And look, here's the actual solution. 2 over 1 times 8 over 8 is going to give us some number over 8, right? It's basically the same thing as 2 over 1. So 2 over 8 times 2 over 1 times 8 over 8 is going to be what in the chat? So remember, when you're multiplying fractions, you multiply across. 2 times 8, 1 times 8. What's 2 times 8, guys, in the chat? 16, right? And 1 times 8 is just going to be 8, okay? And 16 over 8 is the same exact thing as 2, right? So give me a 1 in the chat if that makes sense. Now all we did is we rewrote the number 2 to get it to look like something over 8. Okay, so we can add, now we can combine it with 3 over 8, right?
And if you have any questions, feel free to let me know or unmute, or we're here. All right.
So all we did is we rewrote the number 2 to as 16 over 8, right? By getting a common denominator. And now we have to combine that with what? 3 over 8. What's 16 over 8 plus 3 over 8? Because this is essentially the same thing as 2 plus 3 over 8, right? 2 and 3/8. Cool, right? So 16 over 8 plus the 3 over 8, right, is 16 over 8. I mean by 19 over 8, sorry. 19 over 8, right? Okay,
and guys,
so now
if that's confusing, just whenever you're getting this whole number fraction, this mixed fraction like this, and you want to convert it to an irregular fraction where the numerator is bigger than the denominator, all you need to do is multiply the denominator with the big number and then add the top number. That's it. All right, so it'd be 8 times 2 plus 3. So 8 times 2, 16 plus 3, 19. And then just put it all over 1. All right, so if you want, you can, when I was learning this, I wrote the little multiplication sign, and then I wrote the little addition sign, and that is it. So 8 times 2 is 16. Add 3, that is 19. And then you just have the same denominator. So that's going to be 19 over 8. All right, so that's the first fraction. The next fraction, it is already over 8. So we don't need to do anything. It's just going to be some question mark over 8. Right? So we have some question mark over 8. That's going to be equal to 3 and 4 and 1/4. So doing what we just did for the first fraction, how can we convert 3 and 1/4 into an irregular fraction? We just got to multiply 3 and 4 and then add the 1. So it's going to be 13 over 4. Now we're adding fractions. Can we have different denominators when adding fractions? You guys can just like nod or something. You know, it's okay. Got a single N in the chat. That's good. That's a start. All right. When you're adding fractions, you need to have the same denominator. All right. So if we have a 4, like a denominator of 4 on the right side, we can't have that. We need to change it. Okay. How can we change the 4 so that we have a common denominator? What do we multiply by?
And remember, the goal is to compare these two sides, right? So we see we have a denominator of 8 on the left. What do you multiply 13 over 4 by to have a denominator of 8, right? And again, I don't want you to just say 2. I want you to write it as what? Multiply 13 over 4 by what? Two over 2. There you go, right? So 13 over 4 is the exact same thing as what? As what number over 8? As 26 over 8. Awesome, right? And now we can finally, we have the same denominator across all the fractions, right? So 19 over 8 plus what number over 8 is going to give us 26 over 8, right? 19 plus what is 26, guys? 19 plus what number? Awesome, right? So even if we had something like 19 over 8 plus x over 8 equals 26/8, right? We can subtract the 19/8, right, on both sides. Cancel that out, and we get x/8 equals, when you're subtracting, it's the same deal, right? Keep the denominator, you just subtract the top. 26 minus 19 is 7/8, right? Which means x has to be 7. Great job.
So guys, for this question, first, converting to irregular fractions, all you got to do is multiply the denominator with the big number and add the top number. All right, multiply, add, right? And the reason why we did that to the right side is because we want to make both sides look the same. All right, we have an 8 in the denominator on the left side. We want an 8 on the right side. So we got to get it irregular, and you got to get a common denominator because we're adding. We need a common denominator if we're adding. All right, so multiply and add to get an irregular fraction, and you want them to look the same for this to work on both sides. Make sense, guys? Got a nod or a thumbs up? All right, cool. All right, you guys are alive. Good to know. Let's keep going.
It is actually 2 o'clock, so this is going to be the first session, y'all, first of 4. So we really appreciate your time. So today we went through fractions, right? Absolute value functions, number property distance, and you guys are killing it, right? Again, this is just meant to be like a little preview and review to prepare you for next year, okay? Hope this was helpful. And you guys have any questions before we let you guys go? Nope.
Thank you.
All right, everyone. Thank you so much. Have a good one.